Hi, welcome to Product Review by Robojax. My name is Ahmad Shamshiri. In this video we are going to see how we can use this ZK-PP2K pulse width modulation DC motor controller up to 8 ampere. We can control the motor with duty cycle, and we can change the pulse modulation frequency. We can set separately the on and off time of the signal to control the motor. We can set how many times this should run and how many cycles as well. This is the delay time. When you turn it on, you can just turn it on and off, and this you can get the data sheet and other files related to this by clicking the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. I bought this from AliExpress and for about this much, and with some shipping. I have no affiliation with them. I bought it from my own money, and if you search on AliExpress you will see tons of stores are selling it. You can also buy it from Amazon Canada, Amazon US and Europe. I will provide you the link. So the operating voltage is 3.3 to 30 volts. What it means is this can operate with 3.3 volts, and your motor can be also 3.3. Whatever voltage you connect will be your motor voltage and powering this up at the same time. Frequency can be set from 1 Hz to 150 kHz, and the frequency accuracy is about 2% here. Duty cycle from 0%, which is turned off, to 100%. Maximum current 8 ampere. We are going to test it to see number of pulses. If you want to use it, run it as a pulse, not pulse width modulation, then you can set it from 1 to 10,000, 9,999, or infinite loop, so it can run. You can also set the delay when you turn it on, how long it should wait. And then pulse width also can be set from 0 to 9,999 seconds. So the pulse width, you can set it. Accuracy of time is 1 millisecond. Operating temperature, as you can see, is -20 to 85, which we are not going to be able to test it. Humidity up to 95%. So let's make it clear first that this can run the motor only DC motor and only one way. It can rotate whatever way you put your wire, and that's it. You cannot go the other way. So now let me explain the module. They've labeled it very largely here, and then we have QR code. If you use your mobile phone, you can get the manual. The manual is not easy to use. That's why I made this video. Terminals are also not written properly. They are not in front of each other. I actually connected the positive here, negative here, but fortunately this has protection, and my power supply was not powerful, so this protected it. But if you have powerful power supply, then the diode will blow out. So negative here for the motor, positive. This negative, positive in most DC simple motors like this that I use. For this one, this doesn't matter. I can switch. I can swap the in and out, so my motor can rotate in different direction. But this negative is for this, so this is your power supply. Positive is for here, so positive and negative. And then it can be mounted on the panel. Panel hole that you are going to create is 71 millimeters, 71.1 by 38.6 millimeters, and you have this much depth, 26.2. We have these buttons. With these buttons you will have on the screen two values. The top value, whatever it is, on time or frequency, will be updated with these two, up and down, and these two are for the lower portion of the screen. Does not matter, I'm going to explain it. With the set, you can press it for a longer period, which I'm going to demonstrate, to do settings and other things with this. With this one you can turn on and off the output, and you will see out on the screen when the output is on. Open it here. So these are not good quality. I've seen so many types of these modules. So this is the display driver, and this is the microcontroller from New Photon. This is like Arduino. It's being fully programmed to do this. So question is, if somebody asks, can I change it? No, you cannot, because there are so much wiring and connectivity. So you have to know how this is connected, the display is connected. So out of question. And here we have a terminal where you can control the output on and off using two external wire, which I'm going to demonstrate it. And these are the diodes for protection. When I mentioned when I connected incorrectly, so this will protect it. And this is the main driver. Let's have a look at these. First, this one, the microcontroller. So as you can see, this is from New Photon MS51FB9A. That's a microcontroller. Let's have a look at this chip. So that is TM16218. That is the display driver used for the display. Look at this, the driver, the actual MOSFET that drives the motor. This one says RU3560. And here I found it, this is RU3560. This is from RU chip, so this RU refers to the manufacturer, and it's N-channel power MOSFET, 40 volts, 50 ampere. So this is huge. If you put heatsink, you can go up to 50 ampere. But because it is attached on a PCB, you might not get 50, but maybe 10, 20. For sure, if you put a good heatsink on top, you can do so. So RDS on is 13 milliohm when it is turned on at 10 volts, and it is 18 milliohm when the voltage is reduced. So the higher the voltage, the less losses this will have. I will provide you the data sheet. Let's have a look at this tiny chip. And here this says, and this is M5333. Here is the data sheet for M5333B. As you can see, it has 3 and then XX. And this XX refers to 1.8. If it is 1.8, it will be 1.8, 2.5, and then because it is 3.3, so 3XX means 3.3, so this is 3.3 volts, 200 milliampere. That's the maximum power. So that is a 3.3 volts regulator. Whatever voltage you have, it will receive it and convert it to 3.3 volts. As you can see, the maximum voltage is 35 volts. For that reason, you can connect up to 30 volts that I mentioned. So it is okay, and this will get up to 30 volts, 3.3 volts for the device. Now let me show you the wiring. I've connected here my power supply. This is 4 volts. I've connected here the negative and this one, positive and this. And my motor is 12 volts, but I've connected 4 volts so it can rotate slower and makes less noise for the video. 2 wires for this is connected to this 2 point. You can swap it, the positive and negative like that, so the motor rotates instead of clockwise, counterclockwise. So whichever way you're happy, just connect it that way. But some motors can rotate only in one direction. In that case, pay attention to the positive and negative, and this is the positive if you want to connect it to the proper wire. To understand it, let me first explain this waveform. We have one axis for the voltage, and which goes from 0 to 5 volts. For example, if you connect it to 5 volts, and then on this axis we have time. This is 1 second and 2 seconds. And then we will have a waveform, something like this, which turns on the motor. This is called on time. For certain time, for example, we can set it to 1 second on and then 1 second off. So it will be total 2 seconds. So every 2 seconds, it turns on. For 1 second, the motor is on, 5 volts. If the motor is 5 volts, this is just an example. You can put up to 30 volts. So the motor will be turned on and off. Now, if you want to do it multiple cycles, this is 3 cycles. So the motor on for the same amount of time, on and then off for the same. So this from here to here is the same as from here to this point. So on and off is the same. So we have 1 cycle, 2 cycle and 3 cycle. And so we have 1 cycle, 2 cycle and 3 cycle. And in pulse width modulation, if we have this length is equal to this length, the on time is equal to the off time, then we have 50% on, 50% off. So this is called, the motor is running at 50%. We refer the on, and that's enough because we know the other one. And if we have 30% on, 70% off, so this will be pulse width modulation of 30%. So the motor will run 30% less power, which makes it less 30% less slower. In pulse width modulation, many times I have seen comments, the voltage does not change. So that is the beauty of it. The voltage stays the same. We change the speed using pulse width modulation. And if we have 70% on and then 30% off, then the motor runs at 70% of the power. It will be much faster. And if we don't run it with pulse width modulation, we just want to run it with pulse. For example, we can set it to run for 3 pulse twice. So it runs for 3 and then run again. So this way you can do that as well, and you can set how many pulse you want. Let's say 50 pulse, and you want it 20 times. So once, twice, 3 times, up to 20. Now I've zoomed in so you can see it. So the motor is here. I'll provide you the model of the motor in the description below, the link for the resources page, how we can control a motor and test it. On this screen, if you don't see percent, that is a pulse. So that means 0.7 seconds on, 0.3 seconds off. This is second. So if you have anything behind this, then you can do that. Right side, it shows the off time. For example, you can say, I want the motor to be 2.8 seconds. So have the motor 2.85 seconds off. Now this one, when I change it, this will change the on time, 6.3 seconds on and 2.85 seconds off. Change it. Now we can change it with this and turn it on. But there is another parameter that is affecting this. I have to press this for about 2 seconds. When you release it, you will see it. That's a trick. Hold and release. Now this says 4 seconds, 4.03. Let me change it with this left buttons. You can change the top portion. So you can increase and decrease. I'm decreasing it. This says 4 seconds. So this is the delay time. When you turn it on, when it runs, it waits for 4 seconds before runs. And this portion, it shows how many cycles you want. 5 times, 3 times, whatever. So this, you can increase it now. It means twice, once. And this means infinity. If you want infinite loops, always put it here, so it will continuously run. But let's put it for 5. And then to exit back, press it for 2 seconds and then exit. Now, what it means is, it is for 6.3 seconds on, 2.85 seconds. That's so quick. So 2 seconds, let's change that so we can say 6. So 6 seconds on, 2 seconds off. So remember, initially it will wait 4 seconds and it does it for 5 times. Let's exit by pressing this for 2 seconds. So now it runs for 6 seconds on, 2 seconds off, and it does it 5 times. But when I turn it on, it will wait for 4 seconds. Let me turn it on. 1, 2, 3, 4. So that was 1. 2. 3. 4. 5 and it will stop. That's it. So that was the pulse mode. Guys, do not forget to hit the subscribe button here on the corner of the screen. I really appreciate it. Now let's see the pulse width modulation mode. To go to pulse width modulation mode, press this button and hold it for more than 6 seconds. So you have to hold and wait. Now it turns on. So when you see here the percent sign, then it is now in pulse width modulation mode. In pulse width modulation, it's very simple. This is the frequency, the top, the bottom is the duty cycle. The higher the duty cycle, from 0 to 100, 100 means fastest, and then you bring it lower until you're satisfied with whatever you want. The frequency will affect different motors differently, so I cannot comment on that because it depends on the specification, winding, and many other parameters for the motor. And you will find out at which frequency your motor runs efficiently or at what frequency is needed for your motor. In this case, let's say this is now 1 kilohertz. This side, anything beyond this dot is kilo. So, and then this is the duty cycle. And if I turn it on, just press this on and you will see out. So this is very simple. Now let me increase the speed. Now it's 80%. Now 100%. So this motor is now at 0. It will not turn on at some value. Let's see, 1%. You can hear that sound. So because the power is not enough to turn this on. You see, slowly. At 17 or 18 it started rotating, so it depends on your motor. And also the frequency will affect, but if I want to test it, you see my motor at 6 kilohertz, it will not turn on and off. So it almost stopped. 57 kilohertz. So maybe so it will run like that. It goes every second on and off. And now I've connected a push button to this point with this. This is just a simple DuPont wire, female. And here duty cycle is 45%, and here is my push button. And here when I push it, the output is on and the motor is running. You can just turn it on and off, and this is better. So this is exactly the same functionality of this button here. And here I've connected my power supply to this input. You can read the voltage here. The output of this is connected to my electronic load. Here is the electronic load. This is the electronic load DL3031, and these are the two terminals that from the circuit will be connected in here, and we will see the voltage here and the current. And you will see the virtual software here. the input voltage is also displayed as the output here. So whatever it is, now I have set this to 100%. So in order to check how much this can handle, at 100% it will output the whole power to this. So we will read it here. Now let's go with 1 ampere. As you can see, the output is drawing from here with 1 ampere, and the voltage, as you can see, is 4.2, and this is 4.16. As you can see, 60 millivolts drop here because of the MOSFET. So this is amazing, excellent. Now let's go with 2 ampere. As you can see, we got more voltage drop here, but my wires are very thick wire. These are 60 ampere rated wires, so it's not due to the wiring. Let's see, 3 ampere. So the frequency does not matter here, because whatever frequency we put, 100% means it's just on all the time. Let's go 4 ampere. So let's go 4 ampere. Output is now 4 ampere, as you can see. The voltage is now 4 volts and 20 millivolts drop. 5 ampere. We are getting now 5 ampere. If this was a motor, that's 5 ampere. The voltage does not matter, because we can go up to 30 volts. You can see I just switched the voltage to 12 volts, so it does not matter. So the voltage is now 12 volts, and we are reading 200 millivolts less, 11.8. Now it's 5 ampere. Let's go 6 ampere. And 7 ampere, and let's go 8 ampere, because 8 ampere is the rated current for this. And as you can see, around 370 millivolts drop. This is whatever it is, but let me check this. Whoa, it's so cool, unbelievable. As I mentioned from the datasheet, this MOSFET can handle up to 50 ampere. So now this is getting a little warmer, but definitely 8 ampere is perfect for this. So the voltage, we can go up to 30. And here, as you can see, the voltage is now 30 volts. So this is now I'm using the thermal camera to show you the temperature. As you can see, it shows 51 degrees Celsius at this spot. Let me put my finger. Exactly, that's the spot. So if I remove it, you will see that this is the MOSFET. So very cool, 51 degrees with 8 ampere. Let's go 10 ampere. Now I set it to 10 ampere. This is now getting a little hot. Now let's see with 10 ampere, and here, as you can see, it shows 63 degrees, so it got a little hotter. $65 degrees, it's getting hotter, it seems. 66 degrees, 65. So 10 ampere is not recommended. But if you're wondering about the efficiency is almost 98%. Thank you for watching the tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. In this video, I'm going